You are welcome to this class, and here we are going to consider how we can make these problems that seem complex, how we can make certain terms here a subject of the formula. Let's consider equation 1. Let's consider question 1. Question 1 is T is equals NK plus 1 over 4 UK squared. This is the problem here. How do we make this the subject of the formula? The very first thing we need to do is to clear up the fractions. How do we clear up the fractions? We can make t over 1 nk over 1 plus uk squared over 4. The LCM of the denominators is 4, so we multiply through by the LCM. We have 4 into 1 over 2 equals 4 into nk over 1 plus 4 into uk squared over 4. We try to look out for terms that can divide. We have here 4 here, 1, 4 here, 1, and we have here um, 4 over t equals 4nk plus no, we have here, sorry, here is going to be t over 1, t over 1. So we have 4 times t, we have 4t equals 4nk plus uk squared. This is what we have. And if you look at this term carefully, and you will decide, you discover that we have terms in k that has power 1, and this one in progressive order, and this one power 2. It gives you an idea that this conforms to a quadratic expression or equation. So if we rearrange this to conform to the general form of a quadratic equation, which is the general form of a quadratic equation is ax squared plus bx plus c equals 0. If we try to make this to conform to that, it will become uk squared plus 4nk minus 4t equals 0. So this now conforms to this general form. And if you have a term like this, what do you do? From this, we're able to get, from the general form of the quadratic equation, we're able to get the general formula of a quadratic equation. So if we liken this to the general form of the quadratic equation, then this becomes our a here will be equal to the coefficient of k square, which is u. Our b will become 4n, and our c become minus 4t. Now, the general form of a quadratic equation is given as, in terms of k now, with k equals minus b plus the general form of a quadratic formula. The quadratic formula now, in solving the quadratic equation, is given as minus b plus or minus b squared minus b plus or minus the root of b squared minus 4ac all over 2a. If we then make substitutions into these values now, into this, we'll have this as our result. K is equals minus b. What is b? B is 4n, so minus 4n plus or minus the root of b squared. What is b? B is 4n. Then you have to square it minus 4. What is a? A is u. And what is c? C is minus 40 all over 2a. What is a? A is u. This becomes minus 4n plus or minus 4 squared is 16, n squared. Then we have minus times minus is plus 4 times 4, 16 ut all over 2u. As it is, we can factorize 16. So we have minus 4n plus or minus square root of 16 into n squared plus ut all over 2u. If we take the square root of 16 here, we'll have 4. So this becomes k equals minus 4n plus or minus 4 into the square root of n squared plus ut all over 2u. At this point, we can factorize 2. We can factorize 4 minus 4. If we bring out minus 4, we'll be left with n. We factorize minus 4, then we'll be left with n minus plus 1 into n squared plus ut all over 2u. If we do this, 2 can cancel out 2 here, 2. And the final answer, k, is equal to minus 2 into n minus plus 1 into n squared plus ut. Let me write it up here so that it can be clear. Therefore, k equals minus 2 into n minus plus 1 into square root of n squared plus ut all over u. We have succeeded in making k here the subject of the formula. At this point, you can even stop here and your answer will be correct. Or you take it further by factorizing minus 4, and that is what you have. So let's proceed to example 2 or question 2. We have question 2 now. We have 1 over x squared minus 1 over v raised by n plus 1 over u. We multiply through by the LCM of the denominator. The denominator terms here are s squared, v raised by n, and u. So by the time we multiply through, by that we'll have x squared v raised by n u into 1 over x squared minus x squared v raised by n u into 1 over v raised by n equal to x squared v raised by n u into 1 over u. So this cancels out, and the u here cancels out. So we're left with v raised by n u minus x squared u equals x squared v raised by n. So this is what we have, and the target is to make v the subject of the formula. The target is to make v the subject of the formula, and v is existing in two places here. So if we rearrange terms now, we will have v raised by u minus x squared v raised by n equal to x squared u. We'll make v raised by, we'll factorize v raised by n, I'll be left with u minus x squared because x squared u. By the time we divide both sides by u minus x squared, we have v raised by n equals x squared u all over u minus x squared. Now, to make v the subject of a formula, we have to take the nth root of both sides. The nth root of both sides. If we take the nth root of both sides to make v the subject of a formula, we have v equal to nth root of x squared u all over u minus x squared. This becomes the final answer. I hope you've gotten value from this video. Please remember to subscribe, like, and share this particular video. Please, if there are observations or in the course of the video, or you have any contribution to make, you can drop that on your comment on the comment section. I will look at them. Thank you, and God bless you.